Did you have questions there? Why is it 4 over 1 minus pi over 4?
No, sir.
That was it. That was that problem. To me, that was a straightforward question. And specifically, they were testing, do you know how to read the graph? And a little bit of pre-cal. So they combined a few things together. All right, all you gotta do was plug it in. That was 3D, which I thought was pretty, that was a fair question. It's more complicated than what you used to. It has asked for more than one thing, but to me, that was a fair question. All right, the next one that I saw was 6C. Now that was a harder one. So this one, there's no graph at all. And where's my annotate? There. All right. So 6C is this one right here. So they give you this equation right here. They said it is known that the limit can be evaluated using L'Hopital's rule. So my question to you is, do you know what L'Hopital's rule is? That was one of your questions in the on the review on Delta Math. L'Hopital's rule was one of them. Anybody?
It's like you can put like a straight line through something or something like that.
No.
And then it has to cross it.
No.
No. All right.
So this is specifically when the top and bottom, so let me zoom in here. So I have a little more white space. So this is specifically when you take the limit.
Oh, there's another one.
It doesn't matter what it applies to, and specifically it says 2 in this case. Now this is a hard one. All right, this one is worth a few points because this requires quite a bit of knowledge. Limit as x approaches 2. Now, specifically the top part, and the limit as x approaches 2 of the bottom part. And excuse me for all this extra stuff right here that's popping up. That's my hand. It also writes, but it doesn't write nicely. So if you separate the top and the bottom and they come out to either 0, both of them come out to 0, which is 0 over 0, or infinity over infinity, then that means you can apply L'Hopital's rule because that's indeterminate. Whenever that happens. All right. So if you notice, the first thing we do is you plug in 2. And if you plug in 2, we end up with 2 squared minus 4, which is 0, right? 2 squared minus 4 is 0. You plug in 2. Now, same thing here at the bottom here. Well, they say L'Hopital's rules apply. It says it is known that if you do this, you can use L'Hopital's rule. Well, if we know the top part came out to 0, that means the bottom part has to equal 0 as well. That's a necessity in order to use L'Hopital's rule. So if I plug in 2 now, I know that should equal 0 at the end because that is by L'Hopital's rule. So now your goal is, if you notice, your goal is to find out what F2 is and what F prime of 2 is. And right now we can find F2 because that is right here. That's right there. We can solve for it. So the tricky part was the beginning. Do you understand what you can do with L'Hopital's rule? So how do we solve for F2? Use your algebra skills. Come on, someone tell me the algebra skills, move out how to get F2 by itself.
So do we like move the 1 first?
Sure, we can subtract 1 if you want. So if we do that, then we end up with negative f of 2 cubed equals negative 1.
And then we divide and then
So
do cube root.
that's correct. F2 cubed equals 1. So if I do the cube root, like you said, that would be
1.
there you go. And we have found one of the answers already. We have found this one already. F of 2 is 1. Once again, that's you understanding L'Hopital's rule. In order for you to apply it, 0, 0 over top or infinity over infinity. That's how you can apply L'Hopital's rule. You got questions? All right, you have no questions, then we'll move on to the next step. The next step, we're actually going to apply L'Hopital's rule. Okay, so this one we just proved why L'Hopital's rules apply because it's 0 over 0. So what does L'Hopital's rule actually say? Well, if it's 0 over 0, then by L'Hopital's rule, I know this is true. The limit as x approaches 2 of x squared minus 4 over 1 minus f of x cubed will be the same thing as the limit as x approaches 2. And who remembers the L'Hopital's rule? What can I do? If it's 0 over 0, I can do something with this limit. Does anybody remember from the review that you guys did? Quite a few of you got 100 on that. What can you do with this top part?
To factor it.
The derivative?
Yeah, the derivative is, I forgot, that's 0. Yeah, find the derivative. So the derivative of the top is 2x. And the derivative of the bottom, well, 1 is 0. And what do we do with this right here? The derivative of 1 is 0, so this one will go away. But what about the rest of this? How do you find the derivative of that? It's something to the power of 3. Do you remember we have to do chain rule? The negative is still there. The 3 multiplies to the front. You copy whatever's inside the parentheses. And you subtract the power by 1. Oopsie. But that's not all. After we take care of what's outside the parentheses, we take care of the derivative of what's inside the parentheses. So we multiply by f prime of x. It's a chain rule. All right. Do you have questions? So remember L'Hopital's rule. If you get 0 over 0 when you plug it in, or infinity over infinity, you can just go ahead and take the derivative of top and bottom separately. And then find the limit again. All right. Do you have questions? All right. Now, if you have no questions, I'm gonna have to I think I have to scroll up here because my goal is to figure out what f of f prime of 2 is, because that's the goal right here. This is right here. That's what I gotta find. And there must be some information in here that helps me figure that out. So let me scroll up for a little bit first. Oh, right here. So it does tell me. Let me see. So this requires quite a bit of knowledge. There's no doubt about that. Let me erase this part right here. So like I said, this is not easy. You can see why the AP exam is harder. Now, it says H, which is the one thing that matters to me right now. It's twice differentiable. What does that mean? We say differentiable.
Second derivative?
The derivative exists. At no point is the derivative non-existent. Okay, you can't take the derivative twice and their derivatives exist. All right, so there should be no slope that's undefined. All right, so when you see differentiable, automatically you also must know it is continuous. All right, so you really must understand differentiable and continuous. So for example, that is continuous. That is also differentiable everywhere. There's no point where the slope does not exist. Now, I tried to, let me see, let me erase that. I tried to make a very sharp point, but that didn't come out well. This right here is continuous, but specifically it is not differentiable right here because there's a sharp point. Okay, the slope on the left and the right one will not match. Okay, so that right there, continuous everywhere and differentiable almost everywhere except for this one spot right there, the sharp point. So this cannot happen because it's differentiable. This graph cannot happen for H. All right. So if it has to be differentiable and continuous, then it must look something like this. Now it says right here, H of 2 is 4. That means when X is 2, Y is also 4. And that leads to this answer right here at the bottom. So that leads to this right here. I know that this answer is 2. Oh, no, it says 2 or 4. I think it said 4 actually. Let me go back up. Yeah, H of 2 is 4. All right. So it says right there that H of 2 equals 4. So that means that this right here should be 4. Because there's no way for you to say that H of 2 is 4. So if I drew, here's an example, 1, 2, 3, 4. So I know there's this point right here. There's no way for you to say that the limit is not 4 if it has to be continuous and differentiable. You can't draw it here and make a limit of 2 or a limit of 1. That's not possible because it would not be continuous. It has to be continuous, so that means the limit must point here and here. In order for it to, it has to be 4 itself. And that's why I said this is challenging, because this requires you not just to know one topic at a time. They require you to know many topics like really well for you to understand this question. So I know the answer for this is has to be 4 because it has to be continuous. So specifically when you plug in 2, and it did say when you plug in 2, you get 4. So if I plug in 2, I end up with 4 on top, -3 f of 2 squared f prime of 2 equals 4. So how can we finish this off from there? What are we solving for?
F of prime of 2.
So we're solving for this. So our goal is to get that by itself. That means we should be able to replace this with something else, which we should have the answer to. We solved for it earlier. The answer to that is 1.
1.
So 1 squared is 1. 1 times -3 is -3. Use your algebra skills. What would you do now? We can take all of this right here and multiply it all to the right side to get 4 equals -12 f prime of 2. And it's only one step left. Divide by -12. And we have f prime of 2 is -1/3. The two things they're looking for from the question. That was worth quite a bit of points, and that it requires quite a bit of knowledge in 2019. Do you have questions? Anybody got questions?
No, sir.
All right. Now, the only thing left I want to teach you is one that that I haven't shown yet, and I think it was 6D, if I remember right. Yeah, it was 6D. It was this one right here. Now, this I haven't taught you guys before. I was going to leave it at the very end. This is specifically requires the squeeze theorem. Now, this is important right here. All right, and let me scroll up. Actually, I need one more piece of information that's up there. Right there. All right. This right here. So this is actually pretty simple. All right. And let me erase this. This is called the squeeze theorem, and you'll see why it's called squeezed. So let's look at it graphically first. Let me give you an example of a graph. So let's say you have a graph called g of x, k of x, and h of x, just like with the label right here. Let me give you some random graph. But they said g of x is less than or equal to, h of x is greater than, and you understand k. So this is g, this is h, and k is somewhere in between, which can n equal to. So it can be something like this. And if you touch there, and that would be k. So as you can see, do you agree that k is somewhere in between h and g? Do you guys see that? The graph of k is somewhere in between h and g, and at some point, specifically right here, they're actually exactly equal, the y value. All right? You have questions so far? All right, you guys need to actually respond. Your goal here is to figure out the limits. Now, if this is true, if this is true right here, then the limit as x approaches 2 of what, this one? Oh yeah, specifically 2 of g of x the limit at x approaches 2 of k of x and the limit at x approaches 2 of h of x. So if this is true, this has to be true. The limits of k should be somewhere in between the h and the g. This is somewhere between h and g. This is somewhere between h and g. This is somewhere between h and g, and so forth. As you can see, this is somewhere between h and g. This is somewhere between h and g, right? No matter what you pick, k will be somewhere between h and g or exactly the same, which happens here. All right, that's what I'm saying. Now, do you remember how to prove something is continuous? There were 3 conditions, and we did that. That was quite a bit of work, and I told you that's easily a free response question. How do you prove something is continuous? There were 3 conditions.
Limit from the left and the right are set.
Okay, good. So it must exist. The limit as x approaches, in this particular, that's the second condition you're talking about. Specifically, in this case, 2 of k of x must exist. There must be an answer to this. All right, for this one. Now, there's the what was the first condition? Anybody remember? So
Is
so
it
far,
differentiable?
the second condition we talked about is this right here. The limit exists, but as you can see, that graph is not continuous. This must exist, and somewhere it must exist. That point, the non-calculus question, f of 2 must be defined. All right, so here's the limit existing. Here is f of 2 being undefined, but that is not continuous, and that's why there's a third condition, specifically the limit, the answer to the limit and the answer to the y value must be exactly the same to each other so that they're connected. Oh, why did I put F? Sorry, that has to be K. I shouldn't have put F. Where's the eraser? I had to put K because this is K. I also have to erase this one and put F here. That's supposed to be K. So watch out also for your AP exam on that. As x approaches 2 of K of X. These are the three conditions. This must exist. There has to be an answer to this. It better not be undefined. Number 2, it must exist. It cannot be infinity or never infinity. All right. And number 3, the answer from 1 and 2, those two conditions must be the same. Does that look familiar to you at all? The 3 conditions. All right. The first one is easy. Okay. The first condition is easy. What's K of 2? Well, they gave me this right here. They told me that G of 2 must be less than, because of this, must be less than or equal to K of 2 and must be less than or equal to H of 2. If you know G of 2 here is 4, and you know H of 2 is also 4, then you do understand there's only one value that K of 2 has to be. What's K?
No, wait, 4.
Yeah, it has to be 4, right? Can't be anything else. 4 is less than or equal to K of 2, less than or equal to 4. So you agree that K of 2 has to be 4 itself, right? All right. This statement, if this statement is true, then this has to be true. Therefore, this has to be true. Oh, K of 2 has to be 4. K of 2 has to be 4. There's no way around it. It has to be. So this is done already. All right. K of 2 has to be 4. So the next thing we're doing is the limits. All right. Well, this function is continuous. This function is differentiable. I know the limit of this since G of X, H of X are continuous because they said they're twice differentiable right here, right? Twice differentiable. Therefore, they're continuous. Then this limit, in order for it to be continuous, has to be 4. And this also has to be 4 because of this and being continuous. There's no other choice. If you're continuous, the limit, right? Just like our third condition right here. If you're continuous, you know the y value and the limit has to be the same answer because they are continuous. And the proof for continuity is that those two answers are the same, the y value and the limit. So if that is 4, then this answer to this limit is also 4. The answer to this limit is also 4. And if you see this equation right here, well, it's 4 is less than or equal to the limit as x approaches 2 of k, less than or equal to 4, then there's only one choice. You know that has to be 4 as well, right? Because case in between 4 and 4. Well, there's only one number that can satisfy that. The equal part is 4. And that by the third condition, these two answers are the same. So the third condition is true. Therefore, you can say it is continuous. Do you have questions? I don't know, that was not easy. It requires a lot of knowledge, like I said. The AP exam requires you to know a lot of stuff and actually really understand it. It's not monkey see, monkey do all the time. Do you have any questions there? All right, if you are not asking, and that's all I got for now. And the only thing I can tell you, like I said, if you came in late, I explain the grading policy. The grading policy is essentially your third 9 weeks is your fourth 9 weeks grade. All right, that's what it boils down to. The assignment for today, if you're really taking the AP exam, so really at this point, the only thing that matters for kids is if you're taking the AP exam, that's the only reason I'm doing this at this point, because your grades are set already. Then practice on the 2018 one, which you can see is very different in terms of 2019. Like I said, it changes every year. 2018 to me was easier. It's 5D. Okay, I gave you the link yesterday. If you're too lazy for that, I can show it to you here. Let me go back. And 2018, if you want to just take a screenshot of it, if you're too lazy to do this. And let me scroll down to 5D. Is it 5D? Yeah, 5D. So try it yourself. This is 2018. The only limit question here is 5D. As you can see, it's also based on a graph. And as you can see, there's a graph again. All right, so as you can see, they love doing that. All right. Do you have any questions?
I have two, Mr. Lee.
You have two, yeah.
Okay, first one is so is that for every class? Every class is set on grades, or is that just used?
With the exception of dual credit.
Okay, yeah.
Okay, dual credit is college, is HCC, and they're still going like it's a regular class. You still have a file and so forth. There is no, other than everything's online. For a regular high school class that is not attached to any credit for college, you're set. Like I said, it's on the website. Here, you know what? Let me change the laptop mode, and I'm done here. So laptop mode, so I can type it up for you. It's on the website. So if you just want to read into it, you're more than welcome to. Here, let me get out of this. Stop sharing. Let's see. Stop recording too.